Practicing with decimal to fraction equivalents, meeting the requirements for TEKS 64G. Before we spend time talking about decimal to fraction equivalents, it's worth spending a moment reminding ourselves about place value. This is a critical piece of understanding how to read and then write decimals. So for example, if this is my decimal, then this place value would be the tenths. And this place value would be the hundredths. And this place value would be the thousandths. And this place value would be the 10,000ths. As long as we understand how to read these place values, then it'll be easier for us to make equivalent fractions from our decimals. So if we're working with the decimals 0.4, 0.25, 0.160, then that means we're working with the decimals 4 tenths, 25 hundredths, and 160 thousandths. When I want to write my decimals as equivalent fractions, I'm going to take the name of the decimal and write it as a fraction. So for example, 4 tenths would be written 4 over 10. The 4 is written over its place value of 10. 25 hundredths would be written as 25 over its place value of 100. And finally, 160 thousandths would be written as 160 over its place value of 1,000. So now we've written fractions of equivalent value for these three decimals. So the next step is to make sure that our fractions are simplified. Now, if simplifying fractions is still a challenge for you, I would encourage you to check out the video on simplifying fractions on my YouTube channel. Now, if the most challenging part of simplifying fractions for you is finding and using the greatest common factor, then maybe you could check out my video on greatest common factors on my YouTube channel as well. Now, simplifying these fractions, I see that 4 and 10 share the greatest common factor of 2. And that if I were to divide my numerator and denominator by 2, I would get a simplified fraction of 2/5. So that the fraction equivalent to the decimal 0.4 or 4 tenths is 2/5. Now for our next fraction, 25 over 100, I see that 25 and 100 share the greatest common factor of 25. And that if I were to divide my numerator and denominator by 25, I would get a simplified fraction of 1/4. So that the fraction 1/4 is equivalent to the decimal 0.25 or 25 hundredths. And then finally, I see that 160 and 1,000 share a greatest common factor of 40. and that in fact, if I divide my numerator and denominator by 40, I'm going to get a simplified fraction of 4/25. So that the fraction 4/25, or 4 over 25, is equivalent to the decimal 0.160, or 160 thousandths. Now I want to take a moment to address these two particular decimals. When I write them as fractions, I then realize they can and should be simplified. Now, on the previous slide, I showed you that 25 hundredths share the greatest common factor of 25. But maybe you're struggling to see that or to find that. But you do see that you could divide 25 and 100 by 5. Well, you could absolutely use that. When you simplify by using a common factor other than the greatest common factor, it just means you're going to have to simplify in more than one step. So for example, if I simplify by 5, I'm going to end up with 5 over 20, which can still be simplified. So you would now need to recognize that you could divide 5 and 20 again by 5. That would still bring you eventually to the simplified fraction of 1/4. This is a perfectly acceptable way to simplify. It just takes you more steps and more time. But here, if you didn't realize that 160 and 1,000 share the greatest common factor of 40, but maybe you saw, hey, they both end in 0, which means they can be simplified by 10. Sure, that would work. That would give you 16 over 100. Now, is that simplified? No. But if you then notice, wait a minute, I could simplify 16 and 100 by 4. And when I divide 16 by 4, I get 4, and 100 divided by 4 is 25. You arrive at the same simplified fraction, you just do so in more steps than if you did it directly using the greatest common factor. Now, what if I had a decimal that included a whole number? Say, for example, I had 2.4. Now, if I had 2.4 and I wanted to find its fraction equivalent, the first thing I would do is I would take the whole number 2 and set it to the side. And now I would focus only on the decimal. That decimal of 0.4 is 4/10. So I'm going to write that decimal as a fraction. 4 over its place value of 10. Now I see that 4 and 10 both share a common factor of 2. In fact, that's the greatest common factor they share. Now remember, I'm not dividing the whole number of 2. I'm only dividing the numerator and denominator in my fraction. So my 2 is still the whole number. And 4/10 divided by 2 becomes 2/5. So the decimal 2.4 can be written as the mixed number of 2 and 2/5. So let's try one more of those just to clear up any confusion you might have. If I have the number 3.35, that means I have a whole number, 3, and I have the decimal 0.35, or 35 hundredths. So I can write that decimal 35 over its place value of 100. And now I'm going to simplify. Remember, the 3 is a whole number. It's not being simplified. We're not dividing that 3, so it goes off to the side and waits. I now divide 35 and 100 by their greatest common factor. And I know that 35 and 100 share the greatest common factor of 5. 35 divided by 5 is 7, and 100 divided by 5 is 20. So the mixed number equivalent to the decimal 3.35 is 3 7/20. Let's recap this lesson. Most important thing, place value. I need to be able to read it correctly. I need to be able to recognize that this decimal is 6/10, and that this one is 24 hundredths, and that this one is 107 thousandths. Now, to write equivalent fractions, I take the numerical value, 6, and I write it over the place value, 10. I take the numerical value, 24, and write it over the place value, 100. I take the numerical value, 107, and write it over the place value of 1,000. Then it's important that I look to simplify, which means I need to understand common factors, and preferably the greatest common factor. I'm going to use that to simplify my fractions every time they can be simplified. And then finally, I need to remember whole numbers. If I have a whole number in my decimal being rewritten as a mixed number, I do not simplify or divide my whole number. Do not. But also, do not forget it either. Oftentimes, I'll see students forget to include the whole number. So when they get something that looks like this, 4.25, they'll take the 25 and write it over its place value. And then they'll even remember to simplify it by its GCF, or greatest common factor. And they'll end up with an equivalent fraction of 1/4. And they'll circle this as their answer, completely forgetting about the whole number 4 that was in their original value. So the mixed number equivalent to 4.25 would actually be 4 and the fraction 1/4. 4 1/4. Very important to remember that.